multiple linear regression. So there is a simple differentiation, friends. In the case study aspect, what I'm going to explain is, so just if you refer the case study, is a capstone project kind of thing. So we are making use of sales prediction, or how our TV marketing is affecting the sales that we are making use. And most importantly, in case of the simple linear regression, one important thing is we are having only one independent variable, and so as to find out a particular dependent variable. Okay, so the independent variable generally referred by the notation of the x, and dependent variable is referred by y. So this is how you can refer the SLR, simple linear regression. Whereas the same example, okay, what we are doing is the sales prediction, okay, with respect to TV marketing, radio marketing, and as well as the newspaper. See, the scenario is changed. So in the first scenario, so just we are making use of this particular sales prediction dependent on this TV marketing. Okay, just we are trying to find out the effect of the TV marketing, how it is affecting the sales of the company. So only one parameter we have taken, and accordingly we are computing the sales. Whereas in case of the second capstone, what we are saying is just we are having the data set like which is containing the TV, radio, and newspaper information. Okay, marketing spend and marketing spent on those particular three things, and we are going to compute the sales data. Okay, so here one simple aspect is in case of multi-linear regression. Okay, we are having various independent values. Maybe this is TV marketing and radio, and as well as the newspaper marketing, and we're going to generate the sales y. Okay, a simple narration, like if I am making use of only one parameter, it is simple linear regression. The second parameter is the multiple linear regression. Okay, so this is the scenario. Now in the earlier session, so just we have seen some of the aspects like so there is a linear regression. Okay, and simply what we are doing is we are creating one reference for that to this linear regression, and we are performing some kind of on top of this particular LR, just there is a kind of the fit model. All these things we have seen. And meantime, Venkat, are you ready, or else we'll continue?
Yeah, we can. I'll do whatever I have done. You can.
Okay.
Just...
Okay, then just I'll give 5 to 10 minutes, maybe based on your thing. So only the thing is just you can set the context so that we can make use of those again revisiting in our explanation. Okay, right, go ahead. Okay, you can have a complete narration of that. Okay, so now one more thing, friends, just if you in the next week, however, we are going to start with the naive bias and all those things, but before that, just to have a look on our curriculum also. Okay, curriculum shared by the company, because what we are doing is these things are above and beyond, friends, actually. So whatever we have discussed, like assumptions, and as well as our probability distribution functions, and some other aspects are there actually. So we have seen some of the aspects, so all those things you may not find out in our curriculum actually. Okay, because what I'm doing is recently and latest how companies are asking the questions and what they are expecting from us. So just I am trying to embed those things, friends. Okay, though they are not in the curriculum provided to you, but on above and beyond, we are going to see those aspects also, because it doesn't mean that just completing the course and wind up. Rather, what I am doing is just simply I am dragging you to explain your concepts, whatever you have prepared, so that to build confidence. Second important thing is how you can work, because once the course is done, then again you start from the day one, it won't help you. Okay, parallelly we have to prepare and we have to start. So that's why the reason why I am giving these kind of 5 to 10 minutes talk, okay, which is in line with the current algorithm. So that is what. So if people are ready, maybe Yogesh or Lakshmi, I can give them the naive bias and thereafter SVM. If they are not ready, then same again, Suresh and Venkat will come into the picture and they can take care. Okay, so it all depends, friends. Okay, if you are interested, then we'll, because only the thing is, if all of you are participating and you can explore more and you can have the preparation. So how rather than preparing the content given by me, of course you can use that content as well. And I want to get at least 1 or 2 points. Okay, so at least the different case study or else some kind of the insights, however we are covering, but only the thing is just I want to pull some more case studies or some kind of the capstones, so that you can explain with some kind of examples. Okay, so just to try to do that. And by the way, just you can go through the our curriculum also. So by chance, if you need any clarification on some of the aspects, or generally what we are doing is we have covered up to the ML portion and as well as the NLP kind of thing, some part of TensorFlow and Keras I need to do. So these things you just you, and moreover the probability and as well as the statistics kind of things. And now we are doing with the machine learning algorithms, maybe supervised, unsupervised kind of things. Okay, apart from these kind of things, okay, Keras, however, we are going to talk. And then AI concepts, friends. This is nothing but we have seen artificial neural network and all. I'll show you the implementation also. Okay, that is one thing. And another part is just we are having some SQL thing also in our curriculum. Okay, I'll try to give some kind of the insight in that also, because in case of the data science and machine learning, we generally won't focus much on SQL, but however in the curriculum it is there. So just I will give some of the aspects which are relevant to our SQL. And above and beyond, if you observe, friends, we have seen, see the big data orientation and how our Hadoop ecosystem is supporting the machine learning. And one day just I will spend the Spark orientation also, friend, because the Spark also they may not ask, but at least if you are having the integration of this Spark, actually we are having MLlib, friends, which is very important and which is very commonly used library in case of the PySpark orientation. So I'll try to give some kind of the light on this API also. Okay, that means my intention is not to not only to cover the curriculum whatever we have supplied to you, above and beyond. So which is we are looking from the industry perspective and what exactly the companies are expecting from the members who are already working or who worked as a data engineer or big data developer, and they want to turn into data science zone. Then definitely you need to have at least these kind of the things. And in probability and statistics, many things we have seen. Okay, so starting from the probability and up to the statistics orientation, many aspects we have seen. But still, just I recommend you guys just go back and spend some 10 to 15 minutes of the time on your curriculum. But by chance, if you feel that okay, we have not covered these aspects, then kindly bring to my notice so that I can have a discussion of those aspects also. But majority of the times, friends, I follow the industry curriculum. So whatever the industry is looking for, and if I am talking about the regression, in what way we are using and how people are expecting to involve in those kind of the projects, because based on this simple and multiple and logistic, many companies are working, friends, without touching the classification. So because they are always working with the numbers, and their expectation is also numbers, then obviously the reason is they should work on top of this regression analysis kind of thing only. Okay, and lasso and these ridge regression, friends, as our friend specified. See, while talking about the regression, okay, so just we'll be having the simple linear regression, a multilinear regression, polynomial regression, and lasso, and as well as the ridge. Actually, these two things, friends, actually I can say regularization techniques, regularization and as well as the penalization. Because some of the points, if you see, mainly the regression is a parametric kind of the method, friends. What exactly the parametric is, the parametric, there are certain assumptions, homoscedasticity, heteroscedasticity, and dependency of the independent variables, all these things, okay, they are already assumed actually. So in the implementation, we need not reflect. By why I have covered those aspects is, in general, friends, while talking about the regression, definitely you will be getting one or two questions from that assumptions. Okay, how you treat the dependent variable, and how you are treating the independent variable, and what do you mean by lasso and ridge. These kind of the things nowadays we are asking. That's what I thought of sharing the same with you, though they are not in our curriculum. Okay, so just you have a look on that. Okay, so it's not like only covering the existing things, friends, according to the requirement of our industry. Just I am making use of those kind of the things. Okay, right. And coming to the implementation, friends, I have explained these things in the earlier session, just in a walkthrough way, but today we'll see each and every aspect, how we are making use of the convention of. And one good news is both simple and multiple linear regressions use the class linear regression. Okay, just they are using the linear regression only. Only the differentiation is, in case of the linear regression, we'll be having only one independent variable, whereas in case of the multiple linear regression, we are having the multiple independent variables. Okay, that is only the distinction. Otherwise, the implementation measures and all the exploratory data analysis, okay, all these things are pretty much common, friends. So that we'll spend some time, so that it would be easy for you, so as to capture the understanding of the multiple linear regressions in the simplest way. Okay, have a look on this. So TV marketing sales, already we have seen now, this is known as, friends, what is the first step from the template?
Importing the libraries.
Importing the libraries. So here, just basically we are importing the pandas, and this PD, which is the naming, the suffix of that particular alias of pandas. Directly we can make use of this thing. And we are having one general thing, friends. So just we are having the TV marketing sales information, and that we are reading. Okay, because this is a CSV format, just there is a method called read.csv in our pandas, and we are storing that in the advertisement, that advertising variable. Okay, now one important thing we have seen in the pandas, while discussing pandas, just we have seen how to get the top rows, because we are having many rows, but I don't want to enter, or I don't want to get all those particular rows. Just I want to check up, okay, what is the data initially, so that just if I want to get only 5 rows, friend, just you can take this advertising. Already we have seen this is the variable where you can refer. Okay, now this particular entire CSV file is available with the advertising. Now from this we can make use of the head, okay, which is giving the first 5 records. Initially this particular data set, friends, which is having the TV and as well as the sales information. Okay, our important point here is, on top of this particular data, we are going to establish some kind of the algorithm. And which algorithm we are using, friends, now in this session? Just we are using the simple linear regression. So that is our interest. So now related to this tail, okay, these are all various functionalities, friends, where you want to run through. Okay, maybe we are having the describe, info, head, tail, all those things can be observed. Okay, as a part of that particular thing, I am giving some of the examples. Now we have seen the difference between info and as well as the describe in the earlier example. What is the difference, friends, actually?
Info gives about the rows and
Columns information,
columns
rows
and
and column. Null
any
values are there.
normal
Yeah.
information.
Okay.
Describe gives the descriptive data like the count, name, maybe.
Statistical information. Okay, na? Just you observe, friends. Info just is a basic information related to the rows and columns. And from this, you can easily grasp that whether my data is containing null values or not. If this is containing the null values, then what is the procedure, friends, we need to follow?
The missing value
Imputation. Very good. Missing value imputation. There we are having the simple imputer. So just you can specify missing values equal to NaN and strategy equal to mean, generally followed observation, friends. Okay. So just to recollect. So what we are doing is simply we are building our strategy in such a way that whenever there is a requirement, you can go back and pull that particular concept which we have learned, and we can make use of that convention. Okay. And one more important thing here, why I am talking about this shape is there is one problem with simple linear regression, friends. Problem is how many columns we are having in the independent variable in simple linear regression. In simple linear regression, in independent variables, how many columns we are having?
200. One column only.
One column only. So in that particular case, friends, okay, so if I'm coming up with advertisement dot shape, it is giving the number of rows 200 and columns 2. So we have not, okay, split the data into dependent and as well as the independent. Okay, as per our template, you know, first after getting the data into our workspace, then what we need to do, friends, some description related to the data we need to get, and once that is over, our interest is so as to split the data. But before that, you know, one of the important aspect provided by our Python is matplotlib we are having, and as well as the cburn also we are having. Okay, both the libraries you can use. And what I'm doing here is while talking about the cburn, so just this is available in the import cburn as SNS. Generally, friends, in the preparation or in the team, if someone is talking about SNS dot something, then you have to capture that, oh, we are using the cburn library, because maybe after 100 lines or 110 lines of your code, that means you spend that particular 100 lines of the code throughout your project. Reason behind that is once the data is loaded and you are applying some kind of the exploratory data analysis and data pre-processing, and your entire project is revolving around that particular notebook only. So in that particular case, many at times you see the np dot, pd dot, sns dot, likewise. So you have to remember and recollect that PD, if I am saying, that is a PD is reference of pandas. NP is reference of numpy. SNS is reference of cburn. Okay, PLT is reference of matplotlib. These are all standard convention, friends. Okay, because industry wise and the academic wise also, NP numpy and PD pandas, SNS cburn. You can give your name also, but while using the project, that there should be some common naming convention. That's what we are using this convention. Now, one of the important aspect is just we are making use of okay SNS in the current notebook. And here you see here, friends, the point here is maybe if you are running this particular notebook in distributed environment, I'm having some Dell machine and you may be having some other machine, and Venkat is having some HP, like that we're having different machines, but we need to run that particular code without specific to any machine. So this is to compensate and to neutralize all the hardware kind of the things. So just we are making use of matplotlib inline. So which is nothing but just we are visualizing. Okay, we are not deploying, or we are not going to talk about high-end machines in my current machine. Okay, just I want to use this particular visualization. Further, friend, just we are using the percentage matplotlib inline. If you are not giving also, no problem. But whereas your project is distributed, suppose that you are sharing your file to someone who is running in US or UK, and if you are not giving this percentage matplotlib, definitely the system going to influence this particular visualization. Why I am saying this thing is, friends, because these visualizations and all dependent on the graphics cards. Okay, because every machine is having some graphics cards, maybe the color combination or intensity or type of the color, all these things are influenced by that particular graphics card. So as to work with any kind of the machine, just a good convention to perform, that is percentage matplotlib inline. Okay, just we are using our visualization in the current notebook. For that particular purpose, we are making use of this convention. And if you go back and remember some of the aspects of matplotlib and seaborn, friend, there is one common plot which is known as pair plot. What do you mean by pair plot, friends? Basically,
it gives the resolution.
Pair plot, Venkat. Again, one more thing is you have to rerun the things, friends, because once you close the session, these things won't be in force. So better to rerun all these kind of the aspects. Otherwise, it raise some error whenever there is a non-importing of libraries and all. Okay, so if I am talking about the pair plot, how many number of variables I am having and how they are having the correlation. Okay, so if you are referencing in our example, just what we are doing is just we are making use of this particular pair plot in such a way that, so just our interest is to identify the relationship between, okay, the plots, okay, whatever the data we are having. See, friends, one more problem here is just now I have given matplotlib inline. This pair plot, actually they are deprecated recently. Intentionally I have put this. Now you can go with another plot. Okay, maybe if you are interested in some other plot, so histogram or whichever the plot you want. But you know, periodically this particular SNS, Seaborn or matplotlib, they are keep on adding these kind of the notations. Okay, I will do one thing. You also just you come along with me, friends. Just I am sharing this particular data with you guys. You also start executing the code so that you can already I have shared this notebook with you, and you can download the appropriate whatever the data set. Okay, and you also start with me practicing rather than listening. Okay, just you can also try to implement so that you can see the results along with me. Just you can have a look of this displaying our rows, and you can easily observe how the distinction is there from your machine and my machine. Okay, as I am using the Anaconda navigator and some kind of the latest Python I am using. Okay, so let us see how your system takes these particular instructions. And just this particular thing is info. And then we are this shape is not required, and description of the data, whatever the description I'm having, just we are seeing all the statistical measures of that particular data. And once this is over, visualization. So this one, okay, they deprecated actually, so that this pair plot is not functioning here, matplot. And this one, let me copy this thing also. Yeah, and what exactly the parameters here is, friend, let me explain this, though it is not running. So pair plot is something like, so if I want to get the documentation, what is the command I need to use, friends? If I want to get the documentation instantly,
Shift tab.
Okay, shift tab helps us to understand what exactly the function and how many parameters it is expecting, all these things. Now you just come down, plot pairwise relationship in a data set. So pairwise relationship in a data set, in the sense now we are having TV and as well as the sales data. So just we are expecting the relationship between TV and as well as the sales data. If you observe, yesterday we have seen, friends, the diagram and all. Now just they deprecated so that frequently they use to change those aspects. Okay, that is the reason. Okay, and by default, this function will create a grid of access such that each numeric variable in data will be shared across y-axis. Okay, it is very much helpful whenever you are having the multiple parameters, friends. Maybe if I'm talking the TV, newspaper, radio, definitely we can see the correlation, how TV sales impacting the, how TV marketing is impacting the sales, how newspaper marketing is impacting the sales, and how my radio marketing is impacting the sales, and is there any relationship between TV and newspaper, TV and radio, like that different kinds of the combinations you can see. Okay, and basically friends, every whatever the plots we are seeing, first we have to share the data. Now what is our data here? If you observe, we have stored our data in advertising. Okay, na? We have stored our data in advertising. So what I am referring here, just I am giving the advertising, and my X variable, okay, TV I am giving, my Y variable is however sales, and size of this particular plot, aspect ratio, kind, like that you can give whatever the parameters it is supporting. Okay, it all depends on your creativity, friends. Okay, so this visualization at this moment is not helping us to strengthen our model, only to understand the data. Okay, just you can make use of this particular understanding of the data so that you can run this particular code. And once this is over, next what I am doing is that this thing is a typical statistical model. Okay, again, if you refer this particular simple linear regression, only one statement, or that means one independent variable I am interested. What is my independent variable here, friends, out of this equation? Y equal to C plus M1 into TV. What is my independent variable? This is the independent variable. Just observe here, friends. Directly from this particular thing, from this data set, I can say TV is my independent variable, sales is my dependent variable. So simply what we are doing, Y equal to, in our case, what we are trying to say is Y equal to C plus M1 into TV. We know this TV information. Now we are striving for getting the C and as well as the M1 values. What do you mean by the C, friends? Actually, C is a intercept. And what do you mean by M, which is the coefficient? This particular coefficient, okay, how this particular TV sales affecting this particular M1? Automatically, by substituting this intercept and as well as the coefficient, I know the TV information also, no, so that we can able to generate the sales data. Okay, that is the main important thing, how we are follow up in case of the simple linear regression. And once this is over, next what we are doing is just we are separating the variables. And in the earlier session, we have used that ILOC, and explicitly we have mentioned some kind of the index values. But whereas in case of this example, simply we are specifying the name of the corresponding independent variable. So however, I am having my data in advertising. So just I am picking up only the TV feature. So, and I want to store that particular feature in my variable X. Now onwards, I can say this particular X is nothing but independent variable. Okay. Now, once that is over, friends, now what we are doing, our interest is to separate the Y also. So just simply we are giving the data set name. Okay, whatever the reference I'm having, and we are fetching only the sales information, and finally we are storing the data into Y. So see, clearly I have mentioned this comments also. So putting response variable to Y and print the first 5 rows. Just we are having that head information so that we are getting that one. Up to this, what we have done, simply we have imported the libraries, we have stored the data into advertising, and then exploratory data analysis, and thereafter we are separating that particular X and as well as the Y values. Now this point we have spent quite amount of time in the earlier session also, which is nothing but training and as well as the testing set. Now one difference we have observed, friends, in the earlier session also. What is that we talked about? So we talked about some of the aspects.
Cross validation. Earlier we were doing with the random split. Here we are taking cross validation.
Okay. So earlier we have worked with some kind of the model selection. So just we are not insisting the model so as to observe, okay, the coverage of all the distributions. But what we are doing, just we are making use of, okay, so the cross validation so as to cover all the distributions. What is the benefit of doing so, friends, here? What is the benefit of doing so? Importing all the cross validation. We are balancing or we are covering the entire data. So whatever the data set and whatever the data items we're having, all those particular data items, if I want to balance, then I should use the cross validation. That thing we are performing. Now, is there any difference in usage of the train test split, friends, compared with the model selection? Is there any difference you are observing here?
Random state only we took 100.
Nothing remaining all same, na? That means maybe if you are taking the model selection or if you are taking your cross validation, your train test split is not going to affect. Okay, which are all the parameters I need to take? X value, what is X, friends, here?
X is independent variable.
Independent variable, Y is the dependent, and what is my train size here? Training size, I am putting the 70% we are taking. Random state, okay. That is however the normal data. Now, if I want to get the insight of this particular train test split, okay, just I am running this thing, friends. Okay, it is taking some time because, you know, this is the heart of what happened, no module named. Okay, see here what happened in the earlier thing. Okay, we could see the cross validation kind of aspect. So just if you are making use of, now I can see model selection. So completely they have deprecated and you can run this. Now it could able to fetch. That is what, friends. Okay, intentionally what I am doing is I am pulling some of the aspects. Now what they have done is in the model selection itself, automatically you can go through this whatever the cross validation or whatever the cross k-fold cross validation kind of thing. So that's what, friends. Always what a scaler is doing is keep on adding some new kind of the functionalities. Though whatever the functionality is not worked, you can simply Google it, and instead of that particular cross validation, whatever the advancement they have provided, developer like us, okay, just you can make use of those kind of the convention. Okay, that is what, friends. Don't worry about if you are not knowing also, no problem. Okay, just okay, my cross validation is not working, it is saying some kind of the error, then you can see the alternative. Oh, instead of cross validation, nowadays we are using the model selection. That is the point actually. Okay, but why I have put that particular cross validation is to notify you, though explicitly we are not using that cross validation, but still your advancement of this model selection take care about the kind of the cross validation. Now, if you want to explore more on this train test split, have a look on this. Friends, I am strongly recommending you this Saturday and Sunday, just you at least, okay, you perform the kind of some kind of the documentation understanding. Okay, just you can take one take A4 size sheets or some notes. Okay, just what you can do is you can write down at least the syntax and as well as what is the functionality, okay, related to the train test split. And earlier we are using that simple imputer and one hot encoding, all these kind of things, the most frequently used terms. In some of the cases, friends, maybe the interviewer is very much interested in testing your coding based kind of the skills. Then in that particular case, they may ask you, okay, can you give the syntax of train test split, or can you explain about syntax of the simple imputer? So in that particular case, definitely these kind of things are greatly helps you, friends. Okay, now what exactly this train test split is? Split array or matrices into random train and test subsets. What is the capacity of this random train test subset is the outcome, friends. See, nicely arranged outcome. X train we are getting, X test, Y train, and as well as the Y test we are getting. And apart from that, we are having certain parameters. This is maybe here I am using the train size, but you can use the test size also. Okay, friends, if I am using the test size here, what is the value here? Instead of 0.7, how much value I need to put? Test size 0.3. 0.3, that's it. Okay, maybe this is the thing. And random state, I want to observe, okay, across the corresponding algorithms, if I want to perform some kind of the aspects so that I can make use. Okay, this is initially working of this particular train test split. And basically you can observe all the X train, Y train, X test, Y test. So if you refer these things, friends, somewhere we have seen this series. Can someone explain me what is a series? Long back we have seen actually.
Series is a like list of like it contains the data.
Data. Okay. And
Which can be
what is the difference between array and series?
series is a single
Single array with index. Okay, just it is
single
by
array.
default, it is providing the
If it is
index.
like multiple series, it's called as array, like toward more.
Multiple series is nothing but the data frame. Okay, if I am clubbing all the series, that is what, friends. In pandas, we are having two constructs. One is series, second is the data frame. Series is something like, which is like array, but by default, that particular array is managing the index value. Whereas if I am talking about the data frame is nothing but the combination of the series. So just it is giving the index value and all those kind of the things. Okay. Now, one of the important point we have discussed actually. So like, especially in case of the simple linear regression, we need to update this particular access information. Now you see here also, see that is what, friends, immediately this sklearn, okay, is making use of the advancements so that it is deprecating and is giving the warnings. Okay, so based on our Python version and based on our Anaconda navigation version also, it is going to look that particular thing. And don't worry about the warnings. Okay, as soon as your code is running, maybe this is some advancement might be there instead of this particular new access. Okay, what it is saying, you need to convert this thing into the array, like that it is saying. A reason already we have seen, friends, in the earlier class. What is the reason behind that? Why we need to convert some of the aspects into the array? In the data pre-processing also, we faced this issue actually. There in some aspect, we have converted our data into array. That time Suresh raised the doubt also. Why we need to convert that into the array? That day we have discussed. If someone remembers and recollects, it would be great. You see here, friends, just in the, if you are referencing, yes. Where do we use that particular conversion of the array, friends, in case of one-hot encoding? Okay, because that fit and transform is not giving the array kind of the data. So just what we're doing, we are typecasting. Maybe, typecasting you might be knowing, like conversion of one data type into the another data type. So why we need to typecast to the array is, can someone give the answer, friends? Why we are interested in the array? Friends, important. Why we are interested in the array? I have given the insight also. See, one more time I am explaining that. If you refer the NumPy, on top of this NumPy, pandas built on top of NumPy. And if you are referencing this particular pandas, again, this based on this NumPy, we are your sklearn package is deployed. And on top of this particular thing, we are having the matplotlib. And on top of this matplotlib, I am having the Seaborn library. See the thing. So, however, every thing like sklearn, matplotlib, Seaborn, pandas, all are comfortable, all are compatible with NumPy. Now, what is the construct we are very much used in the NumPy? Which construct we are using in NumPy most frequently? What is that? Someone is saying something. This is nothing but array. Okay. Similarly, if I am saying pandas, which are all the constructs we are frequently used?
Series.
Series and
Data frames.
Very good. Data frames. And in case of matplotlib and Seaborn, okay, pair plot, histogram, okay, bar chart, like that we're having different things. Okay. Now coming to the sklearn, which are all the commonly used things, friends? One is the compose. Second is the
Imputer.
simple imputer.
Model selection.
These things we have to recollect. Model selection,
Encoder, column
one hot encoding, label encoding, or column transformer.
transpose.
And one more important thing, pre-processing is there, na? Pre-processing. So these are all various constructs we are using in the sklearn. Okay, they may ask these things also, friends. Okay, can you name few packages, or can you name a few constructs which are available in sklearn? Then you have to tell compose, simple imputer, model selection, column transformer, pre-processing. Okay, just if you are trying and if you are executing these two, simple linear regression and multiple linear regression, you can able to explain all these things very easily, friends. So you need not by heart also. Okay, don't by heart anything, friends. Okay, just be against to that by heart, just to understand. Maybe it takes some time, maybe 1 or 2 days. Definitely you have to spend that much time, friend, worthful. Okay, now here we'll spend some time, friend, because this is completely new for us. Okay, because up to now somehow we are taking this second example, actually data pre-processing as an extension, but this is a new thing for us. Performing linear regression, performing multiple regression, performing naive bias, performing svm, for all these things this is common, friends. Actually, maybe I can change this thing as a linear regression to multiple regression, or else I may change this linear regression to naive bias. I may change this linear regression to the support vector machine, like that. Okay, just you follow the same convention. Import linear regression from the sklearn. So observe here, friend, there is one construct actually in the sklearn which is known as the linear model. Within that linear model we are having the linear regression. Okay, so just I'm having the linear regression. We are importing this particular linear regression so as to fit our model. Now, once this linear regression is available for us, now what we are doing, friend, just observe here, representing linear regression as LR. Okay, my interest, friend, maybe capital LR or whichever the reference you want. You give your name also. Don't worry about that. But this thing is common. Your L must be capital, R must be capital. So there is a convention, friends, actually, while referencing the classes in object-oriented programming. So just we are making use of every word's first letter as a capital kind of thing. Okay, so that our general convention is we may not directly allow to access the class information, so that we are creating one kind of the reference here. This LR is a reference of this particular linear regression. Now, okay, we got that linear regression and we are having the reference of this particular linear regression. Now we want to establish our model. Now there is a connect here, friends. Now from the conceptualization, what we have observed is, if I want to fit a model, which are all the parameters I should bank on? Which are all the parameters I should give for the fitting of a model? Now let us see what exactly fitting of a model. Just you observe here, shift to tab. Okay, so observe here, friends, fit a linear model. Okay, just it is giving a simple thing, and it is expecting the parameters x and as well as the y. Okay, so x and y means, friends, here it is not directly giving the x train or y train kind of thing, but however in our train test split we identified those particular values as x train and as well as the y train. Don't get confused with the documentation. So here you see training data and as well as the target values, whatever the values we are having. So simply this particular simple linear regression helps us to fit a linear model, right? So after fitting the model, friends, what it is giving as outcome, it is simply giving as the outcome as a linear regression. Just it is giving us, okay, you have fit this particular linear regression, that's all. Now once this is over, now we are ready with our model. Where do we get this model, friends? Where do we get the model outcome now? Where is our model actually? In LR, actually. In LR. Observe here, friends. That is the thing. See, initially in this particular statement, just we are creating a reference of your linear regression. Now what we are doing, we are okay, we are devoting our model to this particular LR, so that whatever the model performance or whatever the model things, whatever the model constructs are there, they are pointing to LR. That point we have to observe, friends. Now our model is pointed to this LR. Okay, with the now you need not go with any X train, Y train, or this linear regression. No need to refer, because our entire model is now packed in LR. That is the advantage, friends, here. So just where we know that fit is a method where it is establishing a simple linear model. Simple linear model between X training and as well as the Y training. What do you mean by X train? What is your X train, friends? This is 4 or 5 time we are discussing. 5th time. Independent. X train is
the TV is
70%.
TV.
Our 70% data, and moreover that particular 70% data we are submitting to our model construction. Okay, now friends, majority of our data we are sending to the model construction. Now this particular LR is containing loaded data, 70% loaded data, and it is having the understanding of the X train and as well as the Y train. Most importantly, now we are going back to this particular discussion. Yeah. Now what we are having, friends, with us, we are having this thing na? And as well as Y also. Observe here. Now we got the information of the TV and as well as the sales. Friends, be with me. This is the very important point, because the same thing is going to adopt. We are going to adopt in every algorithm. Okay, that's what I'm trying to explain as much as possible, so that the same thing, if you are getting the point in the next algorithm, you need not worry about that. Okay, now at the moment you see this, actually this TV now containing in the format of the X training, okay, and Y training. Agree? X train and Y train are available in the TV. Now I want to find out the Y value. Friends, be with me. I want to find out the Y value. Now, which are all the things lagging, friends, here? C and as well as the M1. Okay, C and as well as the M1. Now you see the most advantage of this particular sklearn. Okay, you will be surprised, friends, actually. Now, after giving your X train and as well as the Y train to this particular fit method, you can able to observe what is the intercept value, what is the coefficient value. What is the intercept value and what is the coefficient value? How do you explain this particular thing, friends? What is our intercept value here? Okay, out of this particular thing, just you can refer here. What is your intercept from this equation?
C is the intercept.
Intercept, and M1 is the coefficient. M1 is the coefficient. Now if you see here, friends, okay, so if I am talking about this intercept and coefficient, observe here. Now let me rewrite Y equal to C plus M1 into X1. Let me substitute these values. Y equal to, what is my C here? Intercept, plus what is my M1, friends, here? Coefficient. What is my X1 value, friends, here? TV. Now at the moment I am talking about the intercept and as well as the coefficient. Just have a look on this. Just have a look on this. Now how much intercept I got, friends, here? What is my intercept value? 6.9. Yeah, let me copy that into our OneNote. Yeah, so that means after fitting of model, I got this particular thing. Okay, whatever the value I got here, if you are referencing my intercept and as well as the coefficient, the first value, however, intercept. Now I got this particular thing as a coefficient value. Now tell me, friends, what is the benefit of getting these things? So Y equal to, this is my intercept value, 6.989 plus 0.047, something like that, into my TV. What is the benefit of this thing, this equation, friends? Actually, I am saying this is a model. I am saying this is
just the error decrease.
So we get all the y values based on each
all the Y values. All the Y values. Now, one more thing. Suresh is saying something like, Now, what is the belief on this particular model, friends? As our Venkat rightly said, we can suppose I am giving the value of the TV marketing as $200. Just by substituting in this equation, like I can substitute like this 6.89 plus 0.047 into $205, or else I can give some $300, I can give some $400. Okay, so that is the advantage of the model. But how to prove this model is correct, friends? Can
we
I
have to compare with the actual
that is the thing. See,
the wipe trade, we have to compare with the
logically, friends, you tell me logically, can I stop building up the model here? Logically, can I say this is my model? Can I?
we can say this, but we have to test the
actually I can say this is my model, but I cannot say this is my accurate model or this is my efficient model. Can I, friends? I cannot, because hardly I have implemented my model, but I am not sure whether this model is up to the mark or not. But how to convey that information or how to defend my model is good? What is the process, friends? Many at times we have
Assumptions.
seen. No, not assumptions.
the
What?
actual value.
Now we got this Y predict actually. We got the Y predict. Now we need to compare this Y predict with the Y test. Okay.
That's what Y test minus Y predict.
That is a error term and all. Now, how do I get the Y predict, friends? Now, my Y predict equal to, I need to predict the corresponding values on top of my X test. Now, see one more thing here. Why I am getting this X test into the picture? Friends, just don't be in a hurry to.
We have to see training data. We get some Y value. Now we have to test the data by using this test.
Okay, some more clarity I need. Venkat, just yeah, you are correct, but I need some more explanation. That is not enough. Prediction of Y testing data.
Yeah.
Now you explain. Yeah. Now it is bit easy for you. Yeah.
No, we have given the model the data, training data, X train and Y train. Now we will ensure that the model is like the Y predict, we get it from the testing X test.
That means Y predict
actually with the training data we'll know that yes, the model is okay. The model is good.
Whether this formula, sorry, Suresh.
If we want the values, what we are giving, we have to give it.
No,
you have to see the model.
You cannot interrupt. You cannot interrupt, Suresh. You are not knowing
okay,
that.
I'm sorry. I'm sorry.
The equation what we formed, Y is equal to mx plus c with and then we are checking with the X test data. Whatever.
Yeah, Y equal to mx plus c. That is a old story, na? Again, why you need to talk? Already that is over. See, here our c is there, intercept, our coefficient is also there. We come across those two actually. If you see these values, 6.98 and 0.04, these things are generated from where we have generated these two? From our model only, na? Because our model has given that this is my intercept, this is my coefficient. Okay, we are not satisfied with that. Then what we are doing? We are doing our own way of the prediction, because the possibility here is we know the original outcome and we know the predicted outcome. Now we are going to compare between prediction and as well as the available outcomes. Hope you got the point, friends. They're not that much complex, also simple. So we are not agreeing our model as it is. What we are doing is, that is the probably the next step. If you see here, okay, the next step is what we are doing. We are predicting the thing. This pretty no. Okay, like just in the initial example, we have given the X training and as well as the Y training as the model fitting. But whereas in this particular case, we are giving our X test. Okay, so just with the Y prediction value. Now you tell me this particular Y prediction value, can I say as a Y test values?
No.
No, because Y prediction is nothing but related to our model. Why I am saying model, friend? This LR is containing our model, though I am not referencing. Just observe here, friend. Though I am not referencing, okay, the model directly. This particular LR is containing the model. Reason behind this is this one. With the simple statement, okay, our entire work, our entire thing is packed into this particular LR. Is packed into this LR. Now what we are doing, just we are revolving around that model and we are trying to get some kind of the predictions by giving the X test values. Okay, now that is fine. Okay, just we are okay with that. Now the things come into the picture. This is pretty simple. Nth time we are talking. Which are all the measures we are happy with our regression, friends?
R square adjusted R square.
R square adjusted R square. But here, which are all the measures I am taking?
Mean square error and
R square. Okay, here, friend, maybe directly R square is not available. If you are importing R2 score, then it is equivalent to the R square, friend. Just have a look on that. Now, what is the from where we are importing these things, friends? In the sklearn only, but we are having the matrix. Now you observe in our notebook, actually one note, what we are doing is, so apart from this, these things, again I am referencing sklearn. If I am saying I'm having my compose there, I'm having my model selection, and then pre-processing, and then we are having the imputer or simple imputer kind of thing. Now one more weapon added to our sklearn, and what is that, friends? Matrix. Now you see this composition, model selection, all these things are missing value imputation or encoding kind of aspects. And this pre-processing, okay, directly it is giving that conversion process. Simple imputer. Apart from that, what we have seen, friends, another thing is train test split. This is also one of the important aspect, of course, dependent on the model selection. Now, with respect to this matrix also, friend, what exactly matrix in our terminology? Measures of the regression. Very, very important interview question, friend, because maybe they can ask you like this. In case of the sklearn, which are all the metrics we can use? Which are all the metrics you can use in the regression? Then don't get confused. Measures of the regression, metrics of the regressions are same. Okay, mean squared error. Okay, and as well as the R square and some other also there. I am giving as a task to you so that you can explore root mean square error and as well as the adjusted R square. All those things you can explore. Now, just what we are doing is, yesterday we have seen some kind of the examples given by Suresh. Whether this mean squared error should be less or more?
It should be 0.
It should be 0. If it is 0, we are very good model.
It is a fit model.
Fit model, perfect fit model. However, we won't get that much clarity or perfection. Mean squared error should be only one thing, friend. Error should be less. That's it. Just to remember. And R square value must be higher. Okay. Now you observe here, friends. Our intention is here. On what basis we need to check the errors and as well as the R square values between Y test and as well as the Y predict. What is my Y test actually?
Y test is
Actual data.
Actual data. What is my Y predict?
Data and one is your
Model data.
predicted
Model data. Predicted data. Just observe here, predicted data. Now what we are seeing, we are establishing our mean square error and as well as the R square between y test and as well as the y predict, and we are going to publish the values. What is the interpretation, friends, here? That means compared with
7% of the data.
7% of the deviation is there. Out of 100, 7 values are not correct. Or this our model is not fit up to 7 or 8 values. What about this R square value, friends? 59%.
60%.
And almost 60%. Not bad. Okay, it is okay. Now, just to hold on, friends. What I'm doing is just I'm opening this particular multiple linear regression. Okay. Now, hope you are seeing the screen, friends. MLR, multiple linear regression. Now, all these things are as usual, importing the libraries. And this time what I'm doing is, rather than working on only TV, just we are adding some more things, TV, radio, and as well as the newspaper marketing. This is my data. And you can easily observe how the sales are affected by all these particular three. Okay. Now, this is your typical information and as well as the description of the data. However, and thereafter just we have seen now what exactly the pair plot. You know, friends, here pair plot, what it is giving. Have a look on this. What exactly our pair plot is doing. Have a look. It is spreading over TV, radio, newspaper, and sales. It is trying to give the correlation among those things. Why this particular diagonal is a kind of graph, friend, bar graph kind of thing? Why? Just think through why it is giving these kind of the bar graph.
Both of them are related.
Both are same, not related. See here, TV and as well as the TV, and in this case radio and as well as radio. And of course 100% relation is there with Venkat. That's all, because Venkat I am comparing with Venkat only. So newspaper marketing I am comparing with the newspaper marketing. That's what it is saying, like that, friend. But out of these particular how many are there? 1 2 3 4 1 2 3 4 16 possibilities are there now, because we are having TV, radio, newspaper, and sales. 4 different columns. 4 into 4 16. Okay. And out of these particular thing, which is helpful to us, friends? Which one is helpful to us? Just you think through and you give the answer. Which column especially, or which portion of the data is really helping us?
For every column.
No. Every column, do we really need Venkat?
No.
TV is helping actually. It is going in a graph.
TV sales, newspaper sales, like.
See, so you are all giving the inference, but my question is, let me put this way. Out of these 4 columns, first column, second column, third column, fourth column, which column is giving all the data? I mean, which is trying to give the entire information? Definitely fourth one or third one? Fourth one only. Reason is, see friends, here TV related to sales. Okay, here just if you are referencing radio related to the sales, newspaper related to the sales. Now you can explain. Yeah, Lakshmi, Suresh, and our Venkat, they are saying that TV sales are having, okay, TV marketing is really boosting the sales. What about our radio sales, friends? Radio marketing also somewhat, it is moving in a positive direction. Can you comment on newspaper? This point actually.
It's is also, but not like directly like the radio and.
Yeah, if you observe TV, friends, it is a positive curvature. Just you can easily observe as the marketing is increasing, automatically it is getting affected in the sales also. But whereas, friends, at the moment you are talking about your newspaper kind of aspects, okay, there is a spread actually. It's not actually a trend kind of thing. They are scattered like anything. Okay, that observation you keep. Now what we are doing, friend, just we are separating. What is this step actually?
Actually, Uma, when you see there, the Y test and Y predict errors are more in newspaper.
Yeah, exactly. You are right. That I am going to prove. in a while. Okay, so now we have taken, that is what friends, one more thing. Can you say out of this particular, by seeing this diagram, which is really contributing to our model? Which is really contributing to our model? Which columns are contributing to our model?
The fourth, TV.
TV is contributing, radio is contributing, newspaper, can you say really contributing? I cannot say.
It's giving some other errors.
I'm having some dilemma because outliers are there and spread is also not happy. We are not happy with the spread also because it is behaving odd. Whereas in case of the TV and as well as this kind of the radio marketing, I can easily say some strong association is there. Some I can say these particular things are definitely effect on my sales. Okay, now you observe here what we are doing is just we are splitting the appropriate X value. Very simple friends. Just you need to give the whichever the required values and it is going to post in X and you give the last. What is the sales friends? Actually, this is the dependent. Okay. Now one more important common point here. So model selection, train test split. As usual, we are taking the 70%. One of the important point you observe most of the members in the interviews also friends, what we are going to import from the linear model of the multiple linear regression. Generally, linear regression we are going to import for the simple linear regression. Surprisingly, friends, there is no separate class for the multiple linear regression. We are working with the same kind of the class linear regression. We are going to work with the same linear regression class in case of the multiple regression also. But how a model can able to recognize whether this is a multiple linear regression? How it is going to observe friends, whether it is a multiple or linear?
Is it taking the only one that is directly?
Exactly. Very good. Very good. That means though I am taking the linear regression class for both linear regression implementation and multiple regression implementation, if your independent variable is 1, if our X value is only 1, that is by default, it becomes the linear regression. Whereas if your independent variables are multiple, maybe X1, X2, X3 like that, then it becomes the multiple regression. Other than that, friends, if you observe, all these things are common. All these things are common. Now, what is the coefficient value, friends? Here, you observe here one comment actually Suresh made. Like newspaper is not giving the proper elevations. Yeah, you see here negative value automatically. One more important thing, friends, here. If you are making use of the convention of TV, radio, and newspaper, okay, your TV unit of change in the sales is 0.04, your radio 0.18. Compared with TV, radio is really doing well, friends. And actually, this is negatively contributing. Negatively contributing in the sense it is not having any effect on those particular things. So you can easily say here TV and as well as your radios kind of the whatever the radio advertisements or whatever the spending we are doing, that is having this much effect. And if you see the newspaper, it is a minus symbol.
Well, can you see one thing?
Yeah.
When you were doing only single with the TV, the coefficient was different than when you're putting
exactly.
X1, X2, X3.
Really?
The coefficient of TV is changing here.
Definitely, Suresh, because we are
there seeing... it was 0.06.
Why have you observed that point? Hope you have, because the entire model is driven by TV and as well as the radio and as well as our newspaper. That means they are integrated, and as a whole the model is trying to put the effort. Okay, but even if you are referencing those kind of the aspects, though we are using the extension of the TV, newspaper, and radio, obviously the coefficients and as well as the intercept values are distinct. Intercept also distinct, na? Intercept there, how much we got, 7 point something we got there, but here we got intercept, because that's how your model should behave. Okay, now one more important thing is, now what is our next process? Testing phase. Now you see, friends, what is the mean absolute error here?
1.2.
Earlier?
Means around 10%, 12%.
No. This is only 1
Sir,
point
it is more
more efficient. That means
yeah.
1%
Okay, sorry.
yeah, out of 100 only I can mismatch. Okay, these kind. But whereas if you see this thing, friends, what is the mean squared error? That means mean absolute error square of that one. Okay, that's fine. Your R square value is quite interesting, friend. Have a look on that.
91%.
91%, friends. Okay, that is how you need to observe. Okay, so if I am talking about only the TV marketing, I could able to expect hardly 60% of the prediction or square value. But whereas if I am embedding all my
I think Uma,
yeah,
these coefficients are doing some adjustments over there.
Definitely they have to
decrease that. If you see individually, the paper was looking really bad. I mean, according to our estimation and our thought of what we were seeing over there.
Can we prove that, Suresh? Can we?
I mean, seeing the graph, I'm talking.
Yeah. Let me prove that also. I'm coming to your way.
But the coefficient is trying to decrease the error part and trying to bring it to in a stage where the combination should be very good.
Yeah. Now you see here, friends, what I'm doing is I am explicitly taking the newspaper only. Okay, I don't want to take all these things. Okay, I am dropping this TV, radio, and as well as the sales. That means here, what is the column remains here after dropping? Only newspaper. Okay, newspaper I'm having. Now let me prove that all implementations I am doing, train test split, linear regression, implementation of the model. Now model selection and all. This one, friends, actually, what is my absolute error here? 28.43. That means out of 100, around 29 entries are showing me wrong. What is your R square value here? Friends, have a look on this. Earlier,
7%.
Negative, Suresh, that to see? Minus.
Negative.
Minus value.
Minus value.
R square value should be in higher end, actually 90%, 91%. But this newspaper marketing, it is not at all contributing at the end. It
contributing anything.
Nothing. That is what, friends. So see, practically that whatever a wise data scientist need not code anything at this moment only by just observing the corresponding diagram itself, because it is scattering like anything. Okay, it is not proving anything else. Okay, just if you are referencing this TV and as well as the radio kind of aspect, definitely we are having some sort of correlation related to this model. Okay, that is how you need to observe the orientation of these things, friends. Okay, now what is the difference between linear and multiple in case of the implementation? Any difference we have observed, friends, by the way?
Any of the system is only doing all
that's
the calculations.
All the calculations. Now we are not
the overall percentage. That's what it can be better.
Definitely, here 91% we got, and here mean square error is only 2.29 something. Now what we have done is another thing. This you need to explore, friends. I will talk this thing in the next session. If you remember, we talked about F statistics and as well as some kind of the hypothesis testing, t-test. Okay, all these kind of things, skewness and kurtosis. Some points, have you got the reference, friends?
Yeah, we
have seen all the thing, R squared, adjusted R squared. That means even without doing all these testing and prediction, simply stat model, friends. Actually, what is the stat model is before sklearn, before advent of this sklearn, majority of the machine learning algorithms were tested on top of the stat models only. That time we have to depend on the statistical members because we don't know what exactly F statistic and what do you mean by Z score or what, all the things. Then their demand is more, friend, that time. But unfortunately, they invented this sklearn, and this with the help of the sklearn directly I could able to find out my own metrics, whatever the metrics I interested, mean absolute error, mean squared error, R square like that. Okay, but I'm recommending you guys, though these particular things are not used. Okay, I mean not used in the sense you can, but only the thing is you can directly use this wrapper instead of the statistical measures. But my recommendation would be just to compare these things, friends, into with your stat models, friends. Whatever the stat model I'm having, just your R squared value, and it is showing how much value, how much, friends, R squared value here 0.886. Here I am getting the R square values from 91. So those kind of the distinctions would be there. So just to have a look on that and you come up with our analogy. Okay, just we need to have the correlation of what exactly the t test and as well as the hypothesis testing. Okay, null hypothesis, and this is also important, friend. Durbin-Watson test, omnibus test. Okay, so all these kurtosis and skewness, just to spend some time so that you can get some exploration of all these kind of the statistics. Okay, that's it, guys, and much more. And my
Uma, can we do reverse engineering here?
Exactly. that is a requirement, actually. That is a requirement. Okay, so yeah, you can. Yeah.
One question.
Yeah.
Talked about collinearity,
Collinearity.
Collinearity. So if suppose in this case we think that newspaper, the TV and radio are all like contributing, they are all like this one. Then will the system eliminate any of those variables?
No. Automatic elimination is possible with one statement I have given earlier. Also, we have seen that day we have discussed it. Actually, your question is valid, Venkat. At this moment, at least I can say.
If impacting all the independent variables, then you said that it has to be,
Then what is the procedure we have used that day?
No, we have to find out which one is impacting all those, all the other independent variables.
No. RFE. Again, I am giving some more
dimensionality reduction. Okay.
Alternative to the dimensional reduction, one more point we have discussed.
Okay.
What are all the parameters we are having? Rank we are having. Rank and
support.
Rank and
support.
Support.
Support is true, false.
True or false?
True, false, like that. How many variables I am having? And what do you mean by rank, friends?
Rank 3 will give 3, 4, 1, 3, 5, 7. Yeah.
What do you mean by this RFE? RFE, I'll give you some example. Okay, so simply what we need to do for the RFE, you need to submit some kind of the values, and after giving your model to the RFE, let me explain what is the acronym for RFE.
Recursive feature elimination.
That's all. That's all. Recursive feature elimination. Okay, what it does, just it is giving us the rank and as well as the support. And if you are going with the suggestions of the RFE, you can make use of that RFE mentioned values to build the model. That means I can only select the first column and as well as 2, 3, 4, 5th column, 6th column and 7th column. That means my model can be constructed with the C1, C5, C6 and C7 rather than all the columns. Hope you got the point, Venkat, now.
Yeah, do we do that, or the system automatically?
System automatically it won't do. Only if you are using the RFE, then it can implement for us.
Oh, okay. We have to, when we think that there is a possibility, then we have to use this feature, and then we have to incorporate in the that we are
now running. You tell me one point, friends, by just seeing this particular statement. Let me show you that statement where in this case, have you done any dimensional reduction?
No.
We did not do. Here we have removed,
What do you mean by removal?
Okay.
That is what we reduced the features. We removed the features like TV.
On what basis we have removed? Because see, Suresh removed one feature, and you definitely ask, na? You also there in Suresh team. Fortunately, Fortunately or unfortunately. Okay. So if you are Venkat is questioning Suresh, hey Suresh, why you removed that newspaper? Then Suresh has to tell the answer. Tell the answer in the sense he should not tell, okay, just like that I have removed. Then what is the evidence, Suresh, for this? What is the evidence? Suppose you removed one particular. My net is working. Okay. Are you able to hear me, friends?
Yeah.
So suddenly, yeah. Based on the someone has given the answer. Lakshmi. One is visualization. Second important thing is
all are positively contributing.
They say coefficient negative actually here. He can straight away show this parameters. But to get that parameters, what should we use? Stat model. Observe here, friends. See, if I am stat models, I have not explained intentionally. I will explain in the next session. Okay, because this particular stat model is very, very important in our all the other algorithms also. Though we are not using frequently, but to make some of the conclusions, friends, as our friend told, reverse engineering. Suppose some of the values are not really contributing, and I have to take some kind of the decision because it is giving such a great table, friends. Okay, it is drawing for us actually, in fact, with the simple code. Okay, now one more thing is, if you observe without stat model also, I can able to get the coefficients, like, you know, simply if I am getting this coefficient, obviously I can get this is worst contributor in the order of representation. Okay, this is 0th, first and second. Okay, TV, what is the coefficient value? 0.04. Radio 0.18. What is your third thing? Newspaper minus 0.003. Like that your analysis, friend. Don't think that okay, just someone is explaining to us to eliminate something. At the time of implementation itself, you could able to see clearly, friends. Very first thing is through your visualization. Second important thing is with the help of your coefficient, especially in case of the regression. And in the third point, with the stat model, okay, because it is also giving some kind of the parameters. Then, okay, your stat model, in fact, giving the constant along with the all coefficient values, friends. Okay, all the parameters. That's all. And based on those particular things, we are able to remove that newspaper, and we can see the just to compare, friends. If I'm having the newspaper, TV, and radio, what is my sales, or what is my R square, and what is my root mean square error? And if I am not embedding that newspaper, what is my revenue? Just to have a comparative analysis, and we'll discuss. Okay. So that's all, guys. Very, very important things. These things we have to observe. So spend your this weekend time for me, like, you know, so just these two tasks you need to perform, friends. First task is coding wise, simple linear regression versus multiple linear regression, which are all your observations. Okay, just you give your observations. Second important thing is especially in the case study of sales prediction with TV, radio, and newspaper marketing. Now what is your R2 score and your root mean square error? Whereas if you remove this is A, next thing is only with the TV, radio, how your sales are getting affected. Now you compare R2 score and as well as the RMSE. Okay, so just to come up with these kind of the things, and in the next session we are going to observe the stat models, which is giving the entire aspect. This thing we are going to cover. And next important thing is what do you mean by that KNN, friends?
It measures a distance.
Distance based, which is nothing but the K nearest neighborhood, which is example for the classification. Okay, these things we'll see, friends. Okay, right? And utilize these 2 days okay, for performing these tasks, friend, because though again we are making use of same imports, same kind of the sklearn, same measures, flow is same, friends. Only the thing is you need to be in a position where if you observe the regression, we have used the R square and adjusted R square and all these things. If I'm using KNN, can I use R square and adjusted R square?
No.
What we have to use? Very, very important. That day we have seen confusion matrix, classification, AUC, ROC curve. These things we have to specify. Okay, so and however in Monday session we are going to discuss those particular things, friends. Okay, that's all. And by the way, just to have a look on your curriculum also, by chance, apart from the algorithms, if we miss one or two concepts, just bring to my notice so that we can cover. And above and beyond, we have seen many things. Okay, so once you go through those particular curriculum, definitely you can able to observe which are all the aspects we have covered above and beyond. Okay, that's all, guys. And I overboarded. Sorry for that, because in
thank
between.
You. We are now this part is very good. Like it's
exciting. Yeah. Because see, the thing is now you could able to observe all the points whatever we have discussed in the stats and machine learning algorithms, friends. That is what. Okay, then you can feel the happiness. So after completion of everything, so just if you could able to connect those particular aspects, definitely it gives the confidence, friends.
Myself and Suresh sat till 11:30 in the night again.
Yeah, you are. Yes, Suresh won't let you sleep. He's a good. I mean, whatever he knows, he explains to all. Okay, yeah. And then one more thing, friends. KNN who are going to give some kind of insights. Already, whatever I have covered, KNN revisit, so that we can start the algorithm. Lakshmi, are you okay with that? Your mic is now good, it seems.
I'll try.
No, not try. We are here to achieve the goals. That's all. No try, nothing.
One good thing is once we wanted to do, we try to analyze ourselves,
That is what I'm saying.
So that,
okay. So Lakshmi is going to give some insights of the KNN. Okay, before starting the algorithm implementation. Okay.
Tell me one thing, Uma. Is start model is that tough, like, or that confusing, like, ML is not considering they have a tug of war between start models and ML?
No, actually tug of war is in between in our team only. Suppose I am statistician, you are a cult ML who follows only the sklearn, but my recommendation is stat models, then there should be some Venkat kind of guy. Okay, he should balance us. Okay. Because one more.
But actually, both have to go, shoulder to shoulder. Because
you are right.
Start model is giving the whole strategy,
exactly.
The answer first only. You can see it clearly.
Exactly. You are right, Suresh. That is what I liked you. Whatever the thing you are telling, exactly correct. Because, stat model is such a big summary, actually.
It's a big summary.
See, if you sit and do, definitely take some 20 to 30 minutes to get all the parameters. Whereas our SQL is like classic, just to the point. That's all. Mean absolute error, and it is
to the point, exactly.
Exactly. But your stat model is not like that. Stat model
suits you, Suresh. If you see stat model, you can analyze it clearly. That model, okay, whether it's good or not. You can consider these parameters or not.
Exactly. But the person should know now what F statistic, what do you mean by least square?
That's what I was asking you. Is it that tough, like, to go with everything?
No. Actually, we have seen standard error. Na? We know what exactly standard error. So what do you mean by skewness and what do you mean by kurtosis?
Yes.
All these things. So just you need to spend some time. Whether my values are, if value is greater, then I can happy, or else if value is less, then I can say my model is good.
If you have some time,
that's it.
Explain this also, like,
Sure. No, definitely. Because why I'm saying is, whatever the things we have discussed in the stats, definitely they are going to resemble in this summary table.
Yeah, okay? Exactly.
That is what I have given the task to you. So just to spend some time. However, I'm bringing these things in Monday session. No doubt about that.
Okay.
That's it.
That's good. Okay.
Then anything else? Okay, guys. Thank you. Thank you very much.
Have a nice weekend. Enjoy yourself.
Okay. Bye.
Okay, bye.
Bye-bye.